Today we will discuss the problem number 9 from survey book chapter 25. So let's start. Uh, insulator rod having linear charge density this and linear mass density this is released from the rest with electric field this perpendicular to rod. Determine the speed of rod after it has traveled 2 meter. Okay, and B part and we will solve B later. Okay, let's start from the insulator rod having linear charge density. A linear charge density. Charge density that is given as lambda uh, and that is a 40 micro column per meter. 40 micro is 10 raised to power minus 6 coulomb meter. Okay, linear mass density. The notation may be different for different books, but survey is using this. So I am using this notation 0.1 10 raised to power, sorry, 0.1 kilogram per meter. Or you may say that's 10 raised to power 3 gram per meter. Okay, so this is a mass density is released from the rest. Mean Vi is 0 is released from the rest in uniform electric field, which is electric field is 100 volt per meter. That is perpendicular to the rod. Uh, this is as shown in the fig. That is directly perpendicular to rod. Uh, okay, determine the A part is determine the speed. Vi is given, so Vf is we have to find Vf. We have to find Vf. Vf is we have to find when distance is traveled. Distance is 2 meter. Okay. So how we will find uh, we have to find the kinetic energy, mean velocity, and we have given the range in uniform electric field. Okay. So as we know that delta phi is equal to uh, change in as I have already change in potential energy is equal to negative change in kinetic energy. I have already explained many time, and this change in that this is equal to this, and this is a minus one half m Vf square minus Vi square. Okay. Oh, so uh, mass is given because not mass is given, actually charge density is given. The insulator rod because insulator having charge density this and linear mass density is from the rest. Okay, the speed of rod after it travel 2 meter. Okay, so so what will be the delta phi? So from here we have to find the actually electric field. And we know that electric field is equal to E dot delta L, but delta phi, we know that must choose different. We know that delta phi is equal to E dot E delta L. Okay, delta L. Okay, always remember actually E dot L. and angle between them, that will be because rod is moving between the, because if you study that electric field, electric rod, I mean speed of rod after it has traveled 2 meter, mean that will be move along the rod. So this mean cos will be uh, a zero. That is doesn't mean that is perpendicular. Electric field is perpendicular, but movement of the rod is along the electric field, because this is due to electric field. So that's mean the angle between electric field and rod will be a zero. So that mean that will be equal to 1. So this will be equal to EL. Delta phi will be equal to phi will be the. Now the problem is how we may solve it. Actually, okay. So what will become so EL will be equal to QEL, because due to this minus 1 by 2 m VF square minus VI square. Okay, this become this. As we know that this is given that that is equal to 0, initial velocity is from here, initial velocity is 0. So uh, if we move to here, and so this from this equation you will have VF is equal to 2QEL 2QL divided by M, VF square. Okay, and VF will be equal to, and VF will be equal to 2QEL divided by M square root. Okay, sorry, there here is a minus 2. Uh, Negative sign. I must correct it, I think. Minus. So this will be equal to this. But what is the Q? That is not given. That is not that is separated on the rod. So as we know that because this charge is uh, as we know that Q will be as we know that lambda, which is charge density, that will be a Q over length. And this imply this L is different. So this is the length of rod. Okay. Always remember this charge is distributed on the rod, so that will be L, QL. This L will be, this is the, what is the difference? This is the actually the length of rod, and this L is actually the, this L is actually the distance covered. So always remember this difference. Okay. So always remember that this L is not equal to, so this uh, Q equal to lambda L. And similarly, mass density from mass density, that is mu that is mass per unit length, because this is length of the rod, mass distributed on the rod. And this implies that M will be equal to M will be equal to mu L. Yeah. So putting all these value here, so VF will become minus 2 Q minus Q. Okay. This will be equal to Q is lambda L E L, and mass is mu this L. This L will be cancelled with this, and VF will be equal to minus 2 lambda E L and mu. Okay. This minus will be actually this is negative will be removed. I must remove this. Negative sign will be cancelled, will be removed, will be removed because charge electron will be negative, and minus multiply by minus will be plus. So this is the reason. So due to this, uh, VF will become 2 lambda EL mu square. Okay, 2 square root. So lambda, what is the mean value of lambda? 40 multiplied by 10 raised to power 40 10 raised to power minus 6. Minus 6 or yes. And okay, E is also given. E is 100. E is 100. L is 2 meter. L is 2 meter. E is 100. And mu is 0.1, 0.1 10 raised to power 3. So after computing all these value and calculating, you will get required result, and that will be equal to uh, 0.4 meter per second. So this will be your required result. But now about the B part. According to B part, if the electric field is not perpendicular, because if even electric field, if electric field is not perpendicular, mean if rod is making an angle with the electric field, then what will be effect on okay, if that is making angle 90, sorry, that is making any angle that is not a perpendicular, but that is making angle theta, then what will be happen? Okay, so then because actually motion is along the motion will be always along the sorry, since motion will be since motion will be toward the e, velocity will be along the since will movement since rod rod mm, uh, charged rod movement or uh, velocity will along electric field, therefore therefore changing in changing in angle will not affect and changing the angle will not affect changing angle will not affect. Why? Because it is angle between E and rod. But but angle between rod between electric field and rod movement will remain zero as the case A. So there will be no change in the answer of this problem. For today, it is enough. If you have any comment or questions or any confusion, you please please don't hesitate and put your comment and questions and feedback on the uh, comment box and subscribe my channel. Thank you very much. Allah Hafiz.